Welcome, class. Today we're going to talk a little bit about trig functions and similar right triangles and two special right triangles. First of all, let's just talk about similar triangles. One of these lessons that you're going to be doing is very simple. Let's say that we have this right triangle right here that has a side length of 12, a side length of 5, and a side length of 13. We would be able to find our trig function. Sine, which is opposite over hypotenuse, the sine of angle A would be 5 over 13. Now, if we wanted the sine of this bigger triangle, since it's similar because it has two angles that are the same, a right angle, and they share this angle. By angle, those two triangles are similar. The ratio of this side, opposite side to the hypotenuse of the bigger triangle will also be 5 over 13, or the sine of angle A is still exactly the same. Now, if I look over at these two angles here, as long as angle X is equal to angle A, and we have this right angle here at Z, which is similar to the right angle here at D, the ratio of the opposite side to the hypotenuse is going to be the same as the ratio as the opposite side to the hypotenuse. So even if I don't know this length or this length, I know its ratio is still going to be 5 over 13. In other words, the sine of X is 5 over 13 because it's a similar angle to, or a similar right triangle to A, sine of A. Same thing with here over here. If O, angle O here, is the same measure as angle A, then its sine is going to be the same. The sine of O is going to be the same as the sine of A. So that ratio of the opposite side over the hypotenuse is going to have a ratio of 5 over 13. It might not be 5, it could actually be 10, and this would have to be 26, but it would reduce to 5 over 13. So the ratios of similar triangles are going to be the same. That's actually a very simple lesson, and that should go very quickly. The next thing I want to talk about is two very special triangles that you don't even have to have a reference triangle to do. In other words, if I wanted to look at a 45-45 right triangle, the first thing I want to emphasize is this is isosceles. So an isosceles triangle, it doesn't matter the length of the sides as long as I know that this length here is the same length as this. It's isosceles. These two sides are the same length because these two angles are the same measure. Which what I'm going to do is I'm going to make them 1 and 1. Okay, both a length of 1. Now if I do Pythagorean's theorem, I can find out that this length here, which is going to be 1 squared plus 1 squared, is going to equal that hypotenuse squared, because that's just Pythagorean's theorem, a squared plus b squared equals c squared. Okay, well, 1 squared's 1, 1 squared's 1 equals c squared. 1 plus 1 is 2, is equal to c squared. So this hypotenuse is the square root of 2. Now what that allows me to do is it allows me to find the sine of a 45-degree angle. The sine of a 45-degree angle, which is opposite over hypotenuse, is going to be 1 over the square root of 2, but I rationalize the denominator by multiplying top and bottom by the square root of 2, and I get the square root of 2 over the square root of 2. So the sine of 45 is always going to be the square root of 2 over 2, regardless of the size of the triangle, as long as it's a 45-45 right triangle. The cosine of 45 degrees, by all means, is exactly the same thing because it's adjacent, which has a length of 1 still over this. So it's still 1 over the square root of 2. But again, I rationalize the denominator and I get the square root of 2 over the square root of 2. The tangent of a 45-degree angle is a really nice measure because it's opposite over adjacent. Opposite over it's just 1. Right? And then what's really nice is I can find the cosecant of a 45-degree angle, which is just the reciprocal of the sine. The reciprocal just means it's going to be the square root of 2 over 1, or just the square root of 2. The secant of a 45-degree angle is going to be the reciprocal of the cosine. So again, it's just going to be the square root of 2, because the reciprocal of 1 over the square root of 2 is the square root of 2. The cotangent of 45 degrees is just the reciprocal of the tangent. Well, the reciprocal of 1 is just 1. So again, if you have these written down, the homework will be very, very, very simple and easy for you to find the sine of 45, the cosine of 45, the tangent of 45, the cosecant, the secant, and the cotangent. Another method just very similar to that is for a 30-60 right triangle. But the way I get the 30-60 right triangle is I take an equilateral triangle. An equilateral triangle means all three angles are 60 degrees and all three sides are the same length. And I'm going to cut that equilateral triangle in half. If I cut it in half, this 60-degree angle up here is going to be 30. Now remember, when we take trig functions, it doesn't matter the size of the triangle. So what I'm going to do is I'm going to say this side is 2 on my equilateral, which means this side down here is also 2. Equilateral means all three sides are the same length. But if I cut it in half, then this length here along the bottom is going to be half of 2, which is 1. So this is 1, and this is 2. Now again, I'm going to use Pythagorean's theorem to solve for this missing side here. So then what I'm going to do, again, I'm going to do a squared, which is 1 squared, plus, I'm going to label this as b for a moment, b squared equals 2 squared. 1 squared is 1, plus b squared, 2 squared is 4. B squared equals 4 minus this 1 is going to be 3, or b is the square root of 3. So I come over here and I make this the square root of 3. So now I have the three sides of a 30-60 right triangle, which is going to allow me to find all the trig functions. So for instance, the sine of 60 degrees is going to equal the opposite over the hypotenuse, or it's the square root of 3 over 2. Right? The cosine of 60 degrees is going to equal the adjacent over the hypotenuse, or it's just 1/2. The tangent of 60 degrees is equal to the opposite over the adjacent, square root of 3 over 1. It's just the square root of 3. Now I can find the reciprocals. In other words, the cosecant of 60 degrees is the reciprocal of this. So it's going to be 2 over the square root of 3. But now I need to rationalize the denominator. So I'm going to multiply the bottom and top by square root of 3. So I'm going to get 2 square roots of 3 over 3. That's the cosecant of 60. The secant of 60 is the reciprocal of 1/2. So it's just 2. The cotangent of 60 is the reciprocal of this one. So it's going to be 1 over the square root of 3, which I need to rationalize the denominator. So I'm going to multiply the square root of 3 over square root of 3. I'm going to get the square root of 3 over 3. And there is my cotangent of 60 degrees. Now, I've done the ratios for my 60-degree angle. I'm going to leave it to you to find those ratios of the 30-degree angle. So what I would recommend you do is just turn that triangle so the 30 degrees is here. Right, I'm bringing the 30 here, which the opposite side then is 1. The adjacent side is going to be the square root of 3. And the hypotenuse again is 2. And I'm going to let you find the sine of 30 degrees, the cosine of 30 degrees, the tangent of 30 degrees, and then their reciprocals. The cosecant of 30, the secant of 30, and the cotangent of 30. So again, if you need to review that previous lesson or rewind and remember what this is, and I'm going to maybe walk through it just really quickly, sine of 30 is opposite over hypotenuse. Write it in. Cosine of 30, cosine is adjacent over hypotenuse. Square root of 3 over 2, write it in. Tangent of 30 is opposite over adjacent. 1 over the square root of 3, but then make sure you rationalize your denominator. Cosecant of 30 is the reciprocal of the sine. So whatever you wrote here, flip it upside down, and then make sure you write its or rationalize its denominator if its denominator has a square root in it. Secant of 30 is the reciprocal of the cosine. So whatever you've written here, do its reciprocal. If it has a square root in the denominator, make sure you rationalize. Cotangent of 30 is the reciprocal of the tangent. This should hopefully help you be able to do today's assignments. And if you do have any questions, please do email me or log in and let me know what your concerns are, and I will help you as much as I can.